Alright, let's look at this question. So we want to derive the equation that governs the current I0. Okay, so when this one open, the current source is not connected to the grid to the circuit, so there is only one node. So all current flow out from this node A together should equal to 0, and we can give a name for this voltage across these three components, V0 or V0. So the first current flow through this resistor is V0 over R, and plus the second one, the current flow through a capacitor is C dV dt. Okay, and the last one is I0, because this has been given. Put them together, equal to 0. So what we're going to do is we can think of how much is this V0. So the V0 is across everything, so it's also across the inductor. So we can relate that to I0. So the inductor voltage V0 equals to L dI0 dt. Okay, this is the definition for the inductor. And so the first term we can just plug this in. For the second term is dV dt. So dV0 dt is just take a derivative of this one, so it's equals to the L and the d second order derivative dt square. Okay, so if we plug this one to here and plus this one to here, then we're gonna get this one. So it's L over R and dI0 dt. That's the first term. The second term is C and L second derivative of dI dt and plus AI0. Okay, that's for this one. And this is the first question, and we can move the term a little bit. So we got we put this one at the front, so d second derivative from the highest order to lowest order. Okay, and we divided every term by CL. So second one divided by L, that become 1, and put a C down here, and this is dI0 dt and plus 1 over LC I0 0. Okay, that's the first question. So this is part A. Okay, for part B, let me move up a little bit, just a little bit. For part B, we're gonna do this one. I'm gonna prove that. Okay, so we will take a Laplace transform for the whole circuits, for whole equation. Okay, for every term, because they are linear, we can do it term by term. For the first term, you can see you can do this first term. For this term is the second derivative. Second derivative, we have this form. I just copy down here. So s squared and fs. That means if we take a Laplace transform for this time domain I0, you got an I0s. Okay, that's the Laplace transform for that. So we got I0s, and there are two more terms, minus s f, which is f is I0, and minus a df. I'm going to take that f against I0, make it I0 0 dt, derivative of that one. Okay, so what is the initial current for this one? I0. So initially this one was connected to here. Okay, so I0, sorry, I will write like this. I00 actually equals to all the current from here. Okay, IDC. So this equation becomes I square I0S minus a SIDC and a minus IDC. Here is another IDC. Okay, so a derivative of a constant is 0. Okay, that's the first term. Let me shrink this down a little bit. Okay, now we got this first term, which is this one. And for this term we got di dt. Di dt, we got this one. So it's 1 over SC multiply with a SFS, which is 0S, and minus a initial current. Okay, the initial current, we just did that, is IDC. Okay, we got the second one. The third one is easy. It's just 1 over SC multiply with a IOS. Okay, so we're gonna add this 3 term together, and we also gonna clear the term. Then we got let me clear the term. We got I0S, okay, multiply with S square plus CS plus 1 over LC and equals to IDC S plus 1 over RC. Okay, and you just move terms divided by that one, so you got the final result here. Okay.